This is the sample paper 2014 and it's a trig equation with a few graphs. Now the diagram below shows the graph of the function x equals sin 2x. So that's f of x, that's the sin wave, and you can see that it's 2x, the period then will be pi. That's because normally if it was just sin x, it would get one full period done from 0 to 2 pi radians. But if it's 2x, it gets two full periods in, or cycles in before 2 pi. If it was 3x, it would get 1, 2, 3 in before 2 pi, and so on. Now, on the same diagram above, sketch the graphs of g of x equals sin x and h of x equals 3 sin 2x. So sin x, as we said before, it'll get one full period done every 2 pi. So I'm going to do that in kind of blue. Now note you should always do your graphs in pencil until you get them right. So if it's just sin x, it's going to get one full period done. So, and it's 1 sin 1x, so the maximum height it goes to is 1. So it'll be something like this. So, and then it'll go down. Now you could, in your calculator, you could do shift setup, you could go to radians, okay, shift setup, shift setup number 4, go to radians, and then you could do a table where your function is sin x. Now, you want to start at 0, you want to end at 2 pi. And maybe go up in steps of, say, pi over 4. So pi divided by 4. And then you can see, so 0 is 0. So 0.783 or 1.5 pi or 1.5 would give you 1. It's another way of doing it if you were stuck. Now it's 3 sin 2x. That means this time, so I'm going to do this one in red. It's got the same frequency as the 2x graph that's drawn because sin 2x is drawn. But it's going to go 3 times higher. So it's going to go up to 1 and it's going to go down as far as -3. So it'll be like this. So it cuts the x-axis at the same place. Okay. But it goes up as far as 3, so it just goes 3 times higher and so on. So I know that's a bit messy, but basically this number here, so if you've got y equals a sin bx, this number is the height it goes up to. So for example, if it was 4 sin something, it will go up to 4 and down to -4. And then b is the number of cycles it gets in every 360 degrees or every 2 pi. Now, find the coordinates of the point P in the diagram. Now, you can see in the diagram that the point P is where this dashed line and the black continuous line intersect. Now, I know that this black continuous line is f of x. That's f of x. And I know that this dashed line is 2y equals 1. But remember, f of x, or I can say 2y equals 1, and I can do y equals 1/2. Now, why would I do that? Well, basically, because f of x really means y. So where is f of x equal to y? Where is sin 2x equal to 1 over 2? Okay, so where is it equal to 1 over 2? Sorry, I don't know what that is. Funny. So, find the reference angle. 2x equals sin to the -1 of 1/2. Now remember, we are working in radians here, so it's important that your calculator be in radians. So 2x equals pi over 6 radians. So if we remember now as well from our trig equations that Alfie stole the chickens. So where is sin positive? So this is plus 1/2, so it's positive there. So it's positive in the first quadrant, so do our reference angle. Now remember, the reference angle is always drawn with respect to the x-axis. So since sin is positive in this quadrant, pi over 6 is one of my angles. And the second angle now will be this one. Now remember that there's 2 pi radians in a full turn, so therefore there are pi radians in half a turn. So this angle here will be pi minus pi over 6, so 1 whole, take away 1/6 gives you 5 pi over 6. So therefore the angles in question are 5 pi over 6 and pi over 6. And you might remember from the video the last day or the previous questions, because this is 2x, there's more than just one answer to this. So, and sin of pi over 6 is exactly the same as sin of pi over 6 plus 2 pi. So I add on 2 pi to this. So my answers will be, so add 2 pi onto that. Now if you add 2 pi onto that, and use your calculator to prevent you making a mistake if you need to. We don't want to be making silly errors in these types of questions. So pi over 6, if you add 2 pi onto that, you'll get 13 pi over 6. Now, add another 2 pi onto that. No, we don't need to, because we're actually only interested in solutions, I suppose, between 0 and 2 pi. And then we have 5 pi over 6. Now when you add on 2 pi onto that, you then get 17 pi over 6. And then 2x equals all of those. So then therefore divide them all by 2. To divide by 2, you double the denominator. Nice easy way of remembering that when you're dealing with fractions, just double the denominator. Over 12. Now let's go back up. We have to find the point P. And the point P is so if you look at where does the line and the graph intersect, they intersect once here. This is the second time, this is the third time, and then they intersect there for the fourth time. So it's basically the fourth biggest value. So put these in ascending order. That's so 1, the first, the second, the third, the fourth. So the coordinates of the point P, because this is the fourth one, in terms of size, so it's the fourth value along the x-axis here. So the coordinates of P are 17 over 12 pi. Sorry, 17 over 12 pi, just miswrote that. So 17 over 12 pi, or 17 pi over 12, and 1/2. Now that isn't an easy question, but it is just down to our trig equations, so we need to get practiced on those. This is the key part here. 2x equals pi over 6, or 5 pi over 6. We have to add on 2 pi, or 360 degrees if we're working in degrees, because remember that sin of 60 is the same as sin of 420, which is the same as sin of 780, and so on.